So we have a wonderful topic next because we've been talking about the idea of changes in our space environment, and now we're going to go a little bit closer to home with changes in our own climate environment. And so I want to introduce the next panel. We have leading this panel is Zion Space's founder and CEO, Raha Hakim-Davar. Raha is a mission-driven senior leader with over 15 years of experience leading various efforts to integrate satellite Earth observations into decision-making to address complex climate, water, and environmental challenges. Her experience includes representing the United States government and UN on environmental issues at multiple levels, including support for high-level water and climate negotiations. She is also currently an adjunct professor at Georgetown University and has a PhD from Columbia University. So welcome to our second panel, and Raha, please take it away.
All right, thank you so much. And thank you to all the panelists for joining. We actually realized right before that we have traveled far and to be here. So I think as far as we have Santa Barbara, Qatar, Sweden, and a bit local, but with some traffic to get here. So really, which many of you probably faced as well. So really excited to lead this panel, Accelerating Climate Action with Innovations in Earth Observations. Our home planet is facing major climate and biodiversity crises. We are experiencing more frequent and costly disasters, including wildfires and floods, compromised water and air quality, and growing food security challenges. Continued emissions of greenhouse gases and land degradation are further complicating these outcomes. The time for action is now, mainly because yesterday is already gone, and tomorrow will only be a day later with no change. So whether it's at the intergovernmental level with the Paris agreements, a treaty on climate change, at the enterprise level for climate and biodiversity risk disclosures, or at the consumer level for assessing property risk before making an investment, Earth observations have become a fundamental part of how we consider these areas and a fundamental part of the solutions. Innovations in this space, from acquisition to applications, enable our societies to take more of that creative destruction path to resilience and adaptation. Creative destruction meaning that of innovation stimulated by environmental catastrophe. In other words, we want to do it better than we have done it before. And embracing technology and innovation in tangible and scalable ways is a really key part of doing that. So our panel today is wonderful and very diverse. And what I really am most excited about it is that they represent every part of the Earth observations value chain, from acquisitions to applications and to widespread adoption of EO data. EO meaning Earth observations. So I'm going to do quick introductions, just really going around. And what I would like to do is turn it over to each of the panelists to really introduce themselves and to answer the central question of how your organizations are aiming to accelerate climate action using innovative ways to acquire, disseminate, and integrate Earth observations. All right, so here we have Dr. Jonathan Frame. He's a senior hydrologist at FloodBase. And for those of you that work in this space, FloodBase used to be called Cloud to Street. I'm really excited to see that to follow the story of Cloud to Street from the very beginning of when they were doing very early startup work with NASA funding and some others. And really you have a very focused customer base now and a very clear pathway to Earth observation. So we'll come back and talk more about that. We have Dr. Ritesh Gautam, and he is a lead senior scientist at the Environmental Defense Fund, who, as an NGO, has developed a quite interesting and innovative approach to developing an Earth observations mission via MethaneSat. And hopefully you can tell us more about that and maybe some of the other things, what you're thinking of as a next step, as a follow-on. We have Dr. Essam Hegi. He is, I believe you are the one that traveled the furthest to be here, so really appreciate that and excited He's the chief scientist and director of the Earth Science program at the Qatar Environment and Energy Research Institute. And you were also a long time at JPL as well, scientist there. And he'll talk about kind of a perspective from Qatar and maybe from the region in terms of what the real challenges are and your approach to developing an Earth observations mission that is really trying to target the challenges that you see regionally. And we have Dr. Dalia Kirschbaum, who is a director of Earth Science at the NASA Goddard Space Flight Center. Also traveled far to be here, appreciate that. And you have, besides being in your current role and really leading the path for NASA Goddard's Earth Science work, I was always very impressed by your work on research to applications. And I think that sort of leadership from a research scientist of looking at ways that we can provide information to the user base, particularly on landslides and looking at risk in a tangible way is really innovative, and very excited to have you all with us. Okay, so with that, let me remind you again of that question, and then we can kind of go and do the introductory remarks. And actually also second thing I love about this panel is that we decided to really limit our slides to almost no slides, and that we want to really give time to discussion and hopefully leave time at the end for questions. So please save your questions, fifth row and all the rows. Happy to get to that later. Okay, so question again was, how is your organization, or how are your organizations aiming to accelerate climate action using innovative ways to acquire, disseminate, and integrate Earth observations? Jonathan, we can start with you.
All right, yeah, thanks for having me, appreciate it. Yeah, thanks for the background on FloodBase, so I don't have to mention that we used to be called Cloud to Street, appreciate that. But FloodBase's mission is to reduce the barrier to the necessary scientific information to respond to flooding catastrophes. And that is different for many different communities. So it's actually to reduce the barrier to, on the community scale, to respond to flooding catastrophes. So that is dissemination of Earth observation primarily. I think it might be good to point out that in 2018, FloodBase, what was then called Cloud to Street, was asked to co-host a flood workshop with NASA. And FloodBase had already been established and been disseminating Earth observations to respond to flooding events at that time. But it was actually at that flood workshop in 2018 that a lot of the brainstorming came about to turn FloodBase into the company that it is now. And particularly, one of the main aspects of those conversations from that workshop was some of the gaps, discussing some of the gaps that were missing from the disseminating the information from the observations themselves to the public. And so actually the key component to our current commercial model right now that we have just launched was developed at that workshop in 2018. So the continual feedback between our company and the community is really important. But the way we are trying to work on the dissemination part of that is to really understand flooding at the community level, that they need to understand the information that each community needs to respond appropriately to flooding. And that's different if it's in the Gulf Coast of California, or if it's in West or East Africa, or if it's in India or Bangladesh. So working with the local stakeholders a lot is one of the ways that we try to prioritize disseminating the information.
Awesome, thank you. Lots of questions there that we'll come back to. Ritesh?
Yes, thank you very much for organizing the panel. So Ritesh Gautam from Environmental Defense Fund. For those who may not be familiar with EDF, we are a nonprofit science-based environmental advocacy organization. And it's been a 55-year-old organization. We have about 1,000 people working in science, policy, economics. One of the main areas at EDF, focus areas, has been working on methane emissions for the last 13, 14 years. As some of you may know, methane is a potent greenhouse gas, and it accounts for about 30% of the climate warming that we are experiencing today. And it has a relatively short lifetime compared to, let's say, CO2. Methane lasts in the atmosphere for about a decade. So removal of methane emissions or mitigation of methane emissions can have relatively greater impact in the near-term climate warming. So that's been one of the main focus areas of work. We have, in the last more than a decade, we have focused in the US, North America primarily, coordinating and conducting field campaigns, airborne campaigns on collecting really actionable data on the ground on methane emissions. And what we found that resulted in a paper in Science back in 2018, that 60% of the US oil and gas methane emissions were 60% of that quantity that was measured were higher than what was being reported by ground-based emission inventories, let's say by the US EPA. And clearly, at the time these studies were coming out, the problem of methane emissions was getting kind of global attention. And in order to solve that problem of really producing and obtaining quantitative emissions data globally, the approach was to go remote sensing from space. And so EDF is leading a mission called Methane Sat, which is being launched next year. And it's been in the works for the last 7-8 years. And it will produce quantitative methane emissions data from anthropogenic sectors that include oil and gas, agriculture, landfills, etc. It will operate in target mode. And we also have an airborne version of the mission called Methane Air, which has already flown multiple basins in the US, and regular flights will again start in April of this year. And again, the goal is to really produce quantitative emissions data. So we're not just limited to concentrations data of atmospheric methane, but really operationalizing that whole pipeline of producing emissions data, which the global policy frameworks and regulatory bodies and other stakeholders can directly ingest and use in order to track the emission targets. I'll stop there.
Thank you. Assam?
Okay. Good evening, everyone. So I apologize that I made a long flight, so my tone, my voice is a little bit broken, but I'm very happy to be here. And maybe I'm from the place that is least known in Earth observation, but it is the one where Earth observation is needed the most. Now, you might think of desert area, that nothing happened in desert area. It's a desert. And when I was in PhD, I was like the young student here, I was doing my PhD on water resources in deserts environment. What could be more boring? A desert, people have nothing, and you're gonna find them the things that water. It's very obvious. When I finished my PhD, 2002, that's already 21 years ago, I was lucky to move to NASA, Johnson Space Center, at the Lunar Petri Institute, but not to work on water on the desert, to work on water on Mars. And I worked on the Mars Express mission, the Mars Reconnaissance Orbiter, a couple of rovers, the next rover by ESA, the Lunar Reconnaissance Orbiter to find water on the moon, and participated in the making of the Jupiter sounding radar to look for water on icy moon of Jupiter. And 21 years after finding water on all of these bodies in the solar system, including the one asteroids and comet, I'm back to Earth to apply what I should have done in my PhD, which is to develop a technique to use VHF sounding radar to map aquifers. And that's what we are working on in Qatar Foundation. We are focused on understanding the impact of climate change in arid areas. So what are these impacts of climate change in arid areas and why we should care about? Does it impact us? I want to tell you that arid areas are not an isolated planet. It's not a moon of our own planet. It's a part of our planet. And everything that happens in these arid areas has an impact on every single one of us, including the impact on the fluctuation in the prices of gas, of the oil and gas. So let me give you a simple example. Sea level rise. Most of the areas in the Gulf are at sea level. When I mean at sea level, it's really 1 foot above sea level. Now you have 200 islands that are in the Gulf. And these islands, they are very small, it's a sandy islands, they are inhabited, but they define the maritime border of the Gulf. And when sea level rise and you have coastal erosion, these islands disappear. And when they disappear, there is maritime disputes. And when there is maritime disputes, oil and gas prices, they become higher. If you look to every dispute in the Gulf area, every single one of them, there is an island in that. There is always an island dispute. Somebody claims this island is mine, this island is yours. What is the fact that these islands are dynamic because of the sedimentation and sea level rise of coastal erosion? Do we have the data to observe this? Are we already observing this? Well, the big problem is that many of the Earth observation agencies see that there is no problem to look in desert area. This is why a lot of the instrument requirements are not designed around the problems of arid areas, including the detection of changes, small changes in soil moisture, including the detection of some changes in the groundwater. All of that requires specific missions designed to that. So in Qatar Foundation, what we do is that we put the requirement for these missions. We work with NASA. We have a Space Act agreement with NASA to design a mission concept. It's called Oasis. And it will be the first mission dedicated to impact, to look to the impact of climate change in desert area. It's a concept. It's not yet a mission. And it's going to use VHF sounding radar to map aquifers and to quantify sea level rise globally and in arid areas. That's it.
Well,
Thank you. Dalia?
Yeah, so to kind of round this out and maybe set the stage again, quoting Gavin Schmidt, who's the director of the Goddard Institute for Space Studies in New York, we are entering the era of surprises in how the Earth system is going to respond to climate change. Since 2015, we have consistently broken the 1 degree C threshold relative to 19th century levels. Antarctica sea ice has actually been slowly growing, and after about 2015, it started to rapidly reverse course, and we just had the lowest summer sea ice extent on record. And methane levels have been increasing in the atmosphere recently, and the jury's still out as to why. And so having these foundational capabilities of examining our Earth system, understanding how it's responding, is why the Earth Science Division at Goddard does what it does. So we're home to the largest group of Earth scientists in the world. We have about 1,300 people looking at how we observe, we model, we predict and understand how the Earth is changing. We kind of think of how we can do this in the term surf, turf, and above the Earth, right? We can understand our surface, our oceans, our airborne campaigns, and all the way to satellites. And so we really have end-to-end capabilities in how we develop the next generation of missions and understand the science questions that drive them, developing the new technology to enable those missions, harnessing the data once they launch to create products and provide them to the community in an open forum, and then how we model those observations, assimilate them through two of our key organizations, the Global Modeling and Assimilation Office, which is really a gold standard for how we can bring together those capabilities. We work very, very closely with NOAA and our other research partners around the world, so we can really better understand the past, observe the present, and then project into the future. And so at GISS, the Goddard Institute for Space Studies, we actually have the agency's only climate modeling center. And so they can harness these future projections of climate, couple them with things like agricultural models to look at what yields may be for corn, for and wheat at the end of the century, and understand where the fragility of the system might be. But one of the most important parts, which brings us back here, is how we can harness and integrate those observations for impact through efforts such as the Earth Action activities taking place in Earth Science at NASA, as well as working very closely with stakeholders, with our capacity building programs, with our training programs. We need to go that last mile, working with boundary organizations that can translate to local communities, working with other international partners, federal partners, academia. It's an all hands on deck effort to be able to better utilize all of these observations we have and then conceive of what missions we need to accomplish that transformational science in the future to have real impact in the community. So with that, I think I'll just close by saying, again, all hands on deck effort here, and the partnerships with industry and academia are just fundamental to how we move things forward.
Awesome. Thank you for bringing us back to science as well. I think that that's an area, I mean, it's really interesting with Earth observations in general, because I suspect we did not anticipate as many uses of these data, like 2 decades ago, as we've seen now. So it's really a lot of open questions as to how we translate the science and keep the science integrity while looking for more innovative uses of the data. Innovative uses as in not just for the sake of innovation, but obviously we are seeing that there's real opportunity for us to impact change with the vantage point of space. So I kind of want to go back then to that Earth observations value chain. So kind of, you don't have it all in front of you, but I'll describe a common framework of what that is. So we have acquisition, which is really on the data side. So kind of building, launching, mission development and launching your satellite. Dissemination, so that would be like a data platform where you can disseminate, provide the data that you have from that's been acquired. And then you have everything on the intelligence realm, from analytics to insights to applications. It's very hard to do any one of these things, and it is very hard to do all of these things. So I kind of want to open an open-ended question, a broad question to start with. There are a lot of opportunities for us to use data, or to create, to have new missions, and whether it's on the acquiring side or on the application side, to work across the value chain for climate and mitigation and adaptation. So we have examples of that here. What do you think are the greatest challenges in transforming these data into actionable intelligence? And I think we can, it's, whether that's from a science perspective to help us gain a real understanding of, the changes that we're going to see in the Earth system, but also from an applications perspective. So in other words, where and what are the greatest gaps in the EO value chain? It's for everybody.
So I think I can start by saying, in the Earth observation community, we have a gap for deserts environment that is impressive. It's 12% of the surface of our planet. And if you look to the publication, the sensors, the satellite, the mission, the community, the perception, the view of decision makers about everything in this area is perceived that it's static. And it is not. Let me give you a simple example. If the ice is melting in the polar areas of the Earth, the ice is shrinking, the deserts are expanding. The mechanism by which they expand, the amplitude by which they are expanding, it's still poorly known at the global scale. We know it at the local scale, but we don't know how what is the interconnection between the increase in the surface of desert area and the melting in the ice pole. What's the physics, the mechanism? Can we model that as one system? Keeping in mind that Antarctica and Greenland and the Sahara, the 3 of them are desert area because they do not receive precipitation, but the physics is different. So that is one example. Now, in terms also what we see is water resources. We used to think that water resources is a little dispute between few people, a couple of thousand here, a couple of million there. Now we see in the Eastern Nile Basin in Africa, disputes that involve Egypt, Sudan, Ethiopia. We talk about 300 million people. And why these? We have these disputes on water resource and management because of the interannual variability of the Nile River is not monitored enough, is not observed enough, and rely on rudimentary tools and the station to observe it. We need to have more Earth observations to resolve these disputes because they are accessible to everybody. So the need for Earth observation to go to unclassical areas, like in Africa, like in arid areas, will help mitigate the hardship of water resources, the uncertainty of climate change, but mostly will help establish the peace also between these disputing entities, because everybody can have access to this data, but not everybody can have access to the ground data of each nation when it comes to water resources.
And I'll build on that. I think, in addition to kind of finding new areas to pursue observations, one of the gaps I see that we're really working through is the integration, right? So understanding how those Earth system elements are combined for the future. One example is how can we bring together different communities through transdisciplinary science to really understand kind of the integrated nature. So one of the efforts we have that we've expanded on is the Earth Information System, how we can really bring those products together and elevate them to be actionable and open source for the community, but not only that, to develop open source platforms for others to replicate and conduct analyses in different regions. And I think that one of the gaps that we are continuing to strive for is, for example, working with partners on the ground, boundary organizations, to translate those information into actionable information on the ground, to enable mitigation activities, enable policy changes, but providing a more open and accessible platform to integrate information for understanding those very complex Earth system challenges that we're facing.
Just picking up on that actionable piece and in the value chain, potential gaps in insights and how to create products that are actionable. So I cited some of that in the opening, that in the case of methane and methane SAT, we are not just limited to atmospheric concentrations of methane, but actually trying to produce actionable data on emissions, of how the emissions are originating from, where are they coming from, and how they are changing in time. So some of the existing and previous satellite missions, for example, the Schemaki from ESA, GOSAT by JAXA, and even TROPOMI by the European Space Agency, they produce really, really valuable and science-relevant data on atmospheric concentrations of methane, but it doesn't really tell us how the emissions are changing over time, where are they coming from, and who is responsible for those emissions. So these are some of the questions and data that stakeholders and policymakers want in order to really take that data to action. So data doesn't really lead directly to action. There has to be a transformation in between. And with methane SAT, the emissions requirement was built into the mission right from the beginning, that we're not just limited to concentrations and really producing data up to level 4 methane fluxes. And yeah.
And Jonathan, I would like you to weigh in, but actually I'm going to take a little bit from what was said earlier, and jump ahead for a moment. Floodbase is a commercial company, right? So you are a user of both public and private or other commercial Earth observations data. So, kind of reflecting on what Dahlia said with open science, now this is the year of open science, and I think that is really important to helping us as a global community propel a lot of our ability to innovate. So how do you, where do you see the gaps? So please, weigh in on the question, but also how do you think about that kind of like open science and that science piece in your commercial product?
Yeah, I think that Cloud Street has been very open with our science. Floodbase has been very open with our science from the beginning. We've been publishing papers on everything we do, and that's because what we commercialize is new science that is maybe a couple steps ahead of where most research academic research groups are, but we know that it's only temporary. So, if we figure out some new method of using Earth observations to make an informative decision somewhere, somebody else is going to be right behind us. So it doesn't make sense to try to create some barrier there. It's going to happen anyway. So we try to do our science in the open. Where the commercial side of thing comes is how we use that science to actually help people on the ground make decisions. And that's actually one of the big gaps I see is there's a lot of scientists that are very like global focused and like look at water resources on a global scale or a very large regional scale, and I'm one of them. And there's a lot of scientists that are very like local focused and are looking at just like little regions, maybe, you know, small areas, geographic areas or watershed areas. And those sciences aren't necessarily compatible right now. And so I don't know if I'm trying to say that the gap is in the science, but I think it's also in a way that we kind of have this hierarchy of Earth observations that are either they capture very frequently at a low resolution or they capture very infrequently at a high resolution, and it's not always clear how to use them. And then when we do use them, each community is using them differently. And that's probably the way it should be, but there's some overlap. So if one community is using information that's going to help them solve their really specific problem, and the other community wants to use similar information to help their specific problem, they're independent problems, but there's some overlap there. And I think there's some gap in being able to reproduce a scientific solution to use Earth observations to solve one problem, to solve another problem, even though they're not the same. So one way I envision that is having not only like an Earth observation system that's like global, but have the ability to put in local information into some like global database that says something along the lines of, I use this satellite data to solve this problem, and I also use this local data, and here it is available for my neighboring community to use as well. That's one thing that I've been thinking like about that particular gap.
Yeah, that scaling, it's interesting because pretty much all of you touched on this as well. So that having that local data is really important. Often it's challenging to get, but at the same time, to be able to scale up to the, you know, to have real change. And I mean, you know, in most cases, it's very difficult to create, let's say, a product or something that is that's unique to every specific region, to every specific use case. It's just not very scalable. So, so on that question of data and validation, and again, this is for everybody, you know, how do we fill in those ground-based data gaps? Because that is really important. And I'm going to tack on a second question with that. I think it does fit. It's a question of trust. And again, all of you are, all of the areas that you're working in, because they're actually all like specific verticals. And, you know, in the case of NASA, you're kind of working across many areas. Building that trust is really important, and serving as like Essam, as you said, and Ritesh, you mentioned having like a defensible third-party process that's a real value that Earth observations can bring. So yeah, how do you think about the data challenge? You know, that validation, the local, you know, information that we need to build trust in what we actually have and make it useful, and reflective of the challenges that we're trying to address. And how do you think about that concept of trust, building trust in your product or in any of the data and information?
So if I may say,
it's long and winding, so you can.
So first, when you look to the data of a desert area, as again I show you, you look to many of the hydrological analysis on deserts. You find always that area which is twice the size of the United States in gray. So there is no data, or then the data is poor, or the error is high. You wonder, this is twice of the United States. When we publish a paper, when we go locally to analyze, let's say, one of the basins or one of the river, when you publish this in any journal you submit it, they tell you, oh, this is local study. they don't get it. So journals also do not take local data from these areas. This is why the local ground validation does not go to the community. So one of the issue, what this has made, that the data, there is no ground validation, it has made the Earth observation, the data for arid areas has a high ambiguity. And what that has made the decision makers do not believe in this data, do not account for this data in their decision making. This is why when it comes to make the climate policies or environmental policies in the Middle East, it's always a problem because decision makers think this is ambiguous, this is not clear, there is no ground validation, the sensor is not designed for this at all. You guys are stretching the data, and as a consequence, no action is made. That has been going for decades right now, and it led us to that every problems on water resources, on desertification, on pollution, on natural hazards has become a major issue. I mean, immediately it became a disaster, even though the forces behind it are not major. And this is because of this ambiguity.
Anyone else?
Yeah, I can maybe just take another example of methane, which is on the mind here, on my mind. Building trust is critically important, and different approaches, different measurement platforms can provide different estimates. Just take an example of what's called the IMEO, the International Methane Emissions Observatory, which is housed at the United Nations Environmental Protection, UNEP. So it was launched about a year and a half ago, and the central mandate of their mission is to build and reconcile a data hub of diverse data sources on methane, coming from satellites, coming from ground-based observations, airborne measurements, and even from industry, so oil and gas companies, coal companies, and really reconcile the discrepancies and produce a synthesis of data that can be trusted and used for mitigation purposes and for accelerating climate action. That's I just wanted to mention that as a framework, one of the framework approaches that is being sort of deployed in the methane world.
And can I ask a quick follow-up on that? Because I think that's a really nice example. Where have you seen things that worked well in this global framework, and where do you see the challenges?
So again, we are kind of at the early stages of this kind of framework, but it's working really well, I would say, at least based on the data that we have seen so far. For example, in the Permian Basin in the United States, which accounts for about 50% of the lower 48 oil production in the US. It also happens to be the largest methane-emitting oil and gas basin. We have conducted field measurements there in coordination and collaboration with multiple academic institutes, university PIs, and that has led to a production of really robust data, top-down, bottom-up, sort of a reconciled data. We are very happy with that, and but it's going to be challenging to kind of scale that approach globally. But I think we have found approaches that work on kind of reconciling these bottom-up and top-down.
Yeah, it's really interesting, and I don't recall if you did already mention this, but IMEO, I believe, is organized by the UN Environment, right? So it's a,
Yep.
You know, it's, again, kind of a third party, or maybe a fourth party in this case. So yeah, I think that's very interesting. And then I want to maybe ask you, Dalia, from an Earth information system perspective, how do you think about that integration piece that you really highlighted for us? And, you know, and again, all the other pieces too, that trust and making sure that there's open science and integrity, but really wanted to kind of dig in more on EIS from your perspective.
Sure. Well, I think kind of starting from the ground validation question, right? So we have a tremendous amount of ground networks around the world that are taking that observations and connecting it with our satellite observations. But then I think part of the trust is about engaging people in the process. And so we have quite a few citizen science projects, right, that are connecting people with taking measurements. Some of them are used, some of them maybe are still being archived, but how we engage people in the process of open science, I think that's is where we start with the trust, to grow that transparency. And then I think, as we move into this integration space, the goal that we have is to innovate with new observations and integrate them, and then informing for impact. And I think that's an area where we are still working to kind of broaden the understanding of the archives that we do have to really set the stage for the next decadal set of questions that are out there. And so I think that efforts such as EIS and some of our global modeling analyses, working very closely with NOAA, the Joint Center for Satellite Data Assimilation. There's a new effort called the Joint Effort for Data Assimilation Integration, or JEDI, and that will be really setting new standards for the state-of-the-art in data assimilation, but code repositories that are fully open. So kind of going from that ground-based networks and the satellite observations, creating that open framework to engage at different levels, and then creating these foundational capabilities, working across federal partners to build the next generation of how we do global modeling to inform kind of the high resolution questions we have in desert regions and areas with methane sources. I think that's how we bridge that integration element.
It seems like we have a lot of the pieces, but bringing them all together is going to be is a real challenge. And I guess, I asked about IMEO because that's one, it's a framework where you're trying to bring around a specific use case. You're trying to bring pieces together. So then, Jonathan, from Floodbase, aka Cloud to Street, you're data mission source agnostic, right? You pretty much in terms of what you're willing to ingest into your data product, right? Yes. So what you're really looking for is value add so that you have better predictions, right? Because your customer base, which is the insurance, reinsurance market, looking at what parametric, insurance for floods, right?
That's one of them.
Is that correct? Okay, yeah. That's one of the areas. So, how do you, I guess, where do you see those challenges and where do you see the opportunities when it comes to that, all the data that we're getting, from NASA missions, from others, the commercial sector, what is your process in utilizing, what's the uptake process for these data?
Yeah, this is one of the biggest problems that we have at Floodbase is we have NASA missions that go back, 40 years at some low temporal, maybe low spatial resolution, and we have new private satellites that are extremely high resolution, maybe even high temporal resolution, but they don't go back very far. So we might want to tell a story about some physical process, and both of those sets of information are useful, but the newer high resolution, high temporal resolution information can't really be useful unless it corresponds to the lower resolution. So there's a big problem in being able to index a new satellite with a history from an old satellite. And I guess I'm always focused on detecting water of some sort, but if you detect water with one satellite and another satellite can't detect it, there might be some transformation that you can use, but then how do you know which of the satellites to use going forward? So we're always wrestling with how do you combine observations of multiple types that are trying to detect the same thing? And in a perfect world, they're both detecting water correctly, but we also know that's not true. So there's this gigantic data assimilation problem with the satellites themselves. Maybe that involves like a science physics model that assimilates them, but if two satellites both tell you a different story about where water is, like, you have to assimilate those themselves somehow.
Yeah, and I actually have an example of that. So, we do quite a few, we partner with commercial industry, obviously, and many different data buys from different companies. And so a paper that actually just came out on the front page of Nature from Jim Tucker and his group took 300,000 scenes of sub-Saharan Africa and used JEDI, so different JEDI, looking at this biomass of trees, as well as machine learning to count 10 billion trees in sub-Saharan Africa. Now, why do you want to count individual trees? Well, that tells you about the carbon stock of that region. It's a pretty arid region, but by being able to combine longstanding records like Landsat and new observations with LiDAR technology with commercial imagery, we can now start to understand carbon stores like we've never seen before. And that has huge implications for climate. And this is just one example of kind of those synergies, that integration that machine learning enables, that partnerships with the commercial sector enables, and those long data records for of our land imaging enable. So all of that together can help us to start to solve some of these bigger questions.
So yeah, I guess the answer to your question is how is machine learning is really the big how. And so like we're in this era where we have so much data we don't even know how to use it all, literally. And you know, so the new science, it's not even a new science, the science that's going to help us make use of that data is machine learning.
And okay, awesome. So we have a lot for those looking for things to do. There's sounds like machine learning, so kind of advanced analyses and techniques, and then data fusion is a piece that I heard a lot too, and interoperability. So you know, having data X be interoperable with data Y if you're trying to utilize them, right? So ingest them within the same decision-making framework, whether on the back end or the front end. So I might just ask one more question before we open it up to the audience. So we talked about the data piece and we talked about the observations. You know, what do you think, I guess kind of the question, where do we need to go from here? So I know I'm kind of, it sounds like a closing question and we still have questions, but questions from the audience coming, but really, you know, what are the areas, let's say we have limited funds in all of our organizations, right? So where do you think those funds really need to be targeted? Whether it's from and you all represent different, you know, spaces, which is great. So we have federal perspective, and Delia, you don't have to feel full responsibility for like, you know, just your own perspective on that, your own opinion, for NASA's like stand on things, but yeah, you know, and we have a research organization that I believe you're also tied to the government in Qatar some way, and we have an NGO perspective and then a commercial company. So where do you want to put your energy into?
I might take this first. So as an NGO focused on methane and air quality and some of the pressing environmental problems, we have clear organization-wide goals of seeing emission reduction targets are met. And accordingly, we are closely sort of connected with the global policy frameworks that have pledged or pledges from countries and governments and industry to reduce emissions. So for example, what was signed at the last COP, which was COP27, the Global Methane Pledge, which was an initiative sort of led by the Biden administration and the European Commission last year. And now more than 110 countries have signed to reduce anthropogenic methane emissions 30% by year 2030. And so we are closely connected to that, and MethaneSat will contribute data to that mission of seeing emission reductions and catalyze global action to reduce those emissions. And we are also continuing to organize field campaigns, working with researchers and academic and research institutes all around the world to producing good data, high quality data on methane emissions, empirical quality data. So that's one of the organization goals as an NGO we are kind of focused on within this decade. And pause there.
If we want to hold off and come back to this question, we can also do that. We'll give you some time to think about it. And maybe we move to audience questions for now, and then maybe save the rest of the responses for kind of the last thoughts at the end.
Audience questions are good.
Yeah. Oh, I get to pick? Okay. Right here?
Me? Is this on? Yes, it is. Okay, great. After noticing that a couple topics were not even mentioned at all, can someone on the panel comment on connecting Earth observations with after effects after the spraying, the worldwide campaign of spraying mass particulates in the upper atmosphere, or the beaming of radiation through patented weather modification?
Me.
Yeah, I mean, I think, so we didn't mention that, but I think that there are some interesting natural experiments that are happening, like the Hunga Tonga eruption, right? So these natural emission of water into the stratosphere that's changing our climate, right? And we can see those observations. One of the things that I think we are working on, in addition to developing essentially new chemical transport models to address these events, right? So we see this natural experiment and we can actually pivot to starting to develop new models to address it. One of the things that we're working towards, I'll say, it's an evolving topic, is how we actually couple everything from the troposphere all the way up to the ionosphere, working with the heliophysics community to actually bridge scales in our atmosphere and understand the transport through this, and look at, for example, what happens when satellites come into our different atmospheric layers. So I think that this is an area of evolution, but through modeling with the right data points, we're able to start investigating some of that and look at the attribution and the impacts.
Let's take a question down here. Yes. Right here.
So yeah, howdy. I was wondering, so some of you use information from a variety of satellites, both civil and commercial. I also know that some of the commercial satellite providers, like Planet, like some of the synthetic aperture radar satellite providers, they themselves are getting into the analytics game and starting to provide some analytics products themselves. I guess just how do you see that playing out in the long run? Do you see them as trying to compete, working on different products? Do you see them getting out of the analytics game at some point? Yeah.
I think that's mostly like finding a market opportunity, and there's lots of market opportunities, like the specific work that Floodbase does. Somebody else could start doing it, but nobody else is doing it right now. So we just found a market niche, and we're going towards that. So we do hear rumors that like ISI is doing similar stuff, but every time we actually hear the details, it's not actually what we're doing, so we're not too worried about it. And so I think there's lots of market opportunities out there.
Yes. Let's go right here, and then we'll go in the back. Yes.
There's a lot of comments about a lot of existing data. It's over there. But I had a question about innovations for future data acquisition. In other words, like systems and engineering that might be coming down the road. I guess this would particularly apply to Dr. Hirschhorn and Dr. Heggie. I'm thinking of active remote sensing, such as using lasers and such, new approaches and stuff like that. If you could address, since there's plenty of trust now, what might be coming in the future.
Yeah, I can. And so I think that with this decadal survey that we're implementing called the Earth System Observatory, so there are these new observations that we're conceiving of to launch missions later in this decade. And so active LiDAR to look at our atmosphere is one area where we're really trying to improve the technical maturity of many of these different systems. Some active radar systems that will allow us to see the interaction between clouds and precipitation in different ways. And so we're continuing to kind of mature that technology pipeline to really understand the future of LiDAR, remote sensing, the future of radar, the future of passive remote sensing observations, and look at them, the opportunities to do that synergistically. So one of the missions that we're really focused on at Goddard is the atmosphere observing system, and how we can take instruments provided or develop with industry, with academic partners, et cetera, with the different centers together and look at the processes at the same time. And so I think that that is where some of our new capabilities are going to evolve in this decade, is looking at synergistic measurements with different types, different ways to observe the same process.
Yes, if I may also make a comment on that. I mean, my personal feeling of working in extreme environment, being on the ground, and as an expert reader of the data that I see in the publication, there is a big disconnection. I'm talking again about the arid areas. I'm talking as one example. That is maybe sending us the message that our planet is changing at a faster rate than our program and our instrument development is happening. So is the current programs we have and the current technology development will able to keep with the rapidly changing planet we live on? I'll give you one simple example. 10 years ago, Egypt, where I was born, was a place that had abundance of water. Today, the same nation is one of the poorest nations in water resources. Just in 10 years, because of the climate fluctuation in the Nile Basin, because of the increase in desertification, because of the seawater intrusion in the coastal areas. All of this, it happened so fast within one decade. And now the consequences are increase in food prices and relocation of people. So this is just one example in huge areas that need to be considered in the study of the Earth system. So my thinking is that in the decade, what's coming next, we need to study this globally. There is no island. We are not an isolated island. Every place happen. Every change happen on part of the planet has an impact one way or another on the other places. And we need to keep that in mind when we design the next missions and when we design the program to acquire the data, which is right now, it's work in progress, at least what I say, not in the atmosphere part, but in the land part.
Sorry?
Somebody has been waiting to ask a question.
Oh, okay, can you point them to me? There, I think we had a couple of people here in the audience too.
Yeah, people have been saying the microphones for a while.
Oh, okay. All right, so let's go. They were also raising their hands. They just didn't get up. So let's take a question from the fifth row, and then we'll go to the mic, and hopefully we have enough time.
So as we continue to acquire more data and make more observations into these issues, how would you start to weigh spending on the continued research into that observation technology versus spending on solutions to the problems that we've discovered cause this climate issue?
And actually, let's hold off. Can we also get the question from the gentleman in the back as well? Maybe we can. That's you, sir.
Okay. I thought I was in the middle, but
no.
maybe I've been promoted
it feels
to the
like the
fifth
back
row.
from here.
So my question kind of has to do with NASA's push for commercialization in a lot of the across NASA, and it really feels to me like climate change and the amount of money spent for disaster relief and mitigation and floods and things like that. Seems like that's one place where money is really flowing, more so than maybe in, say, the heliophysics, disaster relief that we just heard about. Can you say a little bit about how you might develop a business model and whether you see the commercialization of all of the data that you're collecting turning into companies that are then making money and doing innovations? Or do you see all the innovation kind of staying in the NGO and government side?
We have two questions.
Do you want to start?
Can I take a crack at the first one?
Mm-hmm. Yep.
I don't know how this is going to come off, but I'll say it anyway. I think a lot of times the more we spend trying to figure out a giant, big solution to thing, the more time we're wasting not spending time looking for small solutions that are right there in front of us.
And I kind of view for both of those questions, I think that there's space for both. I think we need to make space for both, right? So, the role of some of the NGOs, the role of NASA is developing some of that foundational technology, some of the foundational research needs and modeling capabilities, and working either in a co-development capacity or transition capacity to some of the other groups. At the same time, I think there are some amazing examples of creating business cases from some of that data to then create a market. So one of those, in the reinsurance industry or things like Agvesto, right? It's a small reinsurance agricultural company that we've talked to, and they bring in SMAP, they bring in GPM, soil moisture precipitation, and they have now created a huge market working with farmers in several different regions. So I think that there are absolutely both, and there will continue to be into the future. But they have different roles in the space.
Great, thank you.
And my sincere apologies, sir, for not seeing you in the middle to the left of me. I just wasn't turning that way, so please go ahead. We'll take
No
one
problem,
more.
just a quick question. Paul Galloway, Teledyne FLIR. I'm a commercial. We operate a commercial hyperspectral imager on ISS, DESIS. And really the question is looking at building a new methane detector for ISS, and it takes a substantial investment to build a new detector for space, millions of dollars. Most companies really have a good business model before they do that. The question is for Dr. Gautam. How do you see the commercial market for methane data? And that would be on the emitter side and the enforcement side.
Right. So the commercial sector specifically for methane is an active a sector. So there's a company called GHGSat operating out of Canada, which has a constellation, I believe, of 6 or 7 microsats now, which are provide services to oil and gas and coal and other industrial companies to monitor their methane emissions from their facilities. So their spatial resolution is about 30 meters by 30 meters, so they can really pinpoint to individual plumes. So there is a growing market. As an NGO, we are committed to providing methane emissions data freely available to the public domain, but that's different from the commercial sector. So GHGSat is working closely with the industry, but they're also contributing to initiatives like IMEO, which I mentioned earlier. So they're contributing their data in a sort of anonymized form, which the IMEO can also use and integrate with other observations. So I believe there's a growing market across governments, NGOs, and commercial focused on methane and other greenhouse gases.
And I think we're at time.
If I may say one word, the private sector has a growing role in developing nation in EO, especially in Africa and the Middle East, where the decision makers, the policy makers, the community do not have a local space agency or do not have a lot of activities in remote sensing. And so they rely on the product of the private sector, and they trust the product of the private sector more than they trust the published research by international universities or international agencies. And for one reason, because they pay for this product. So they know it is made for them, but they don't know what is published is made for them, or they are in the error bars, or they are on the marginal side of things. So this is why the private sector right now, Africa and Middle East, especially in EO, is growing very fast.
Wonderful. Thank you so much. And thank you to the panel. Thank you for your great questions. And I think we are going to go into a break now. So.